All right, so we're going to start with the warm-up and then go over your homework. Today is the last day we have to review to get ready for the common assessment because the Monday is the common assessment. We were going to do it today, so I have pushed it back an extra day. With that being said, I know that a lot of you don't study, and I also know that especially on the weekends you don't study. But I do advise, like when you're sitting in here Monday morning for the 30 minutes before school, you might want to look through this review packet before we take the common assessment during third period. Just because I tried, it's not the same questions, but I tried to pick problems that were similar so that you would be prepared. So I would look through this. Even, Sunday afternoon or something, not asking you to do the math, just asking you to look through and see what we did. As we go through stuff today, if something doesn't seem as familiar to you, like you feel like you might need, just put a star beside it so you make sure, hey, if I look back at this paper and I only pick one to look at, make sure I look at this one kind of thing. All right. But I ask you to do number 5. But before I ask you to do number 5, I want to point something out in number 4 because I'm afraid I'll forget if I don't. And then we'll look at number 5. I'm not going to ask you to do number 4 right now for time's sake, but there is a word in it that I want to make sure you know. I don't think this word is on the common assessment, but it could be on the EOC. And and now we're looking at both. So when we look at number 4, it says the Greens bought a condominium for $110,000 in 2010 if the value appreciates. So the other day we did depreciates. And what did depreciate mean? Goes down in value. So like that's what happens with cars and machines and computers, even phones. Like you buy a new iPhone, you could pay $1,100, $1,200 if you get the highest one they have. Whereas in like a year's time, it is not worth anywhere near that. Even if it's brand new, they've got a new model out. Yes.
What number did you do?
I told you to do number 5. But we're looking at number 4 for the word appreciate.
Oh, okay.
Because I was afraid I'd forget. So I wanted you to know appreciate means goes up in value. And there are things in life that go up in value. A lot of times real estate is one of them. And this is a condo, and condos can go up in value. For instance, if you had beachfront property in Myrtle Beach back in 1990, it is worth a whole lot more now in 2021 if someone was to buy it from you than what you paid for it probably did. So real estate does appreciate in value. Sometimes it also depreciates. Some go down, especially if something bad happens in that town and people aren't moving in like they were in the past. So I just wanted you to know appreciate means to go up in value, whereas depreciate means to go down in value. Okay, so those are opposite words. For depreciate, you use the decay formula with the subtraction. Appreciate, you would use the growth formula with addition. Okay? Number 5, during the 1990s, the forested area of Guatemala decreased at an average rate of 1.7%. How could a forest area decrease? People are cutting down trees, deforestation, or forest fires. But if it's depreciating over years of time, there's probably not a forest fire lasting for years and years and years. But forest fires do make some of it go away. But most of the time, it's humans that cause this to happen. They're either cutting down trees because they want the wood, or they're cutting down trees because they're trying to move into that area. So the forest is decreasing. And so it says if the forested area in Guatemala in 1990 was about 34,400 square kilometers, write an equation for the forested area T years after 1990. And so this is growth, or is this decay? Decay. So we're going to say y equals, and for no matter whether it's growth, decay, or compound interest, the first thing that's there is your initial value. Okay, so your initial value is how much? 34,400. And then what does the 1 stand for inside of that parentheses? I ask this class every day during my 5th period because I want them to know it by the time, but I always forget to ask. Thank you. I forget to ask in here most days. It means 100% because we got to account for the first 100%. And then we're subtracting from that. So we're subtracting the percent as a decimal. So what is 1.7% as a decimal?
0.017.
0.017. Very good. And then we just put that to the t power. So regular growth and regular decay does not require the dividing by the number of times a year because it's only happening one time per year. And then that takes care of A. For B, you'd say if this trend continues, predict the forested area in 2015. So the first thing we got to do is figure out how many years is 2015 after 1990? 25 years. So I'm going to take that problem and I'm just going to use this calculator for time's sake and type it in, but instead of T, I'm going to put 25. And I get 22,407.7 square kilometers. 0.65 is fine. If it was on a test, I'd tell you what I wanted you to round to. But you could put 0.65. That's the same thing there. Now, with that being said, Ashley, I do want to keep in mind, if it says people or animals, you cannot have a part of a person or a part of an animal. So you would need to round it to the nearest whole number, not decimal, when it comes to people or animals. If it's money, how many decimal places do we have to round to? 2. But if it's an area of something, like an area of land, you can round to the nearest 10th or 100th or 1000th of an acre, a kilometer, or whatever, because you can have part of a square kilometer. Questions on anything dealing with growth, decay, or compound interest? There's one more thing I want to tell you in this packet before we go to your homework. And I wanted to, I think it might be on the first page here. Turn to the first page of your packet. The exponential one, the one we had our warm-up in. Now, this first part here, transformations, it says if B is a whole number. That is not exactly correct. The part that's in parentheses is exactly correct. If B is, well, actually, we don't want to put greater than 0. We want to put if B is greater than 1. So do this for me and put B greater than 1. If B is greater than 1, your graph is going to look like this. Is this graph increasing or decreasing? Increasing. So if B is greater than 1, it is a growth. So if you're looking at an equation and it in parentheses is 3.5 to the x power, you know that is a growth. But if B is between 0 and 1, meaning it's a decimal or a fraction, the graph looks like this. Is that an increase or a decrease? A decrease. So that would be a decay. So what I wanted to point out to you is if you look at an exponential equation and the number being raised to the x power is bigger than 1, it's a growth. If the number is smaller than 1, it's a decay. Now, we have looked at that in the word problems we've been doing, because 1 plus something gives you a number bigger than 1, and 1 minus something gives you a number smaller than 1. And when it's minus, it's a decay, and when it's plus, it's a growth. Any questions there? All right, there's one other thing I want us to look at, growth and decay, before we leave today, but I'm going to save it at the end of class to kind of make a growth and decay sandwich with class. Remember at the beginning, switch to something else, and remember again at the end. So if you would get your homework out, and let's look at the answers to your homework. So you were supposed to do 22, 23, 24, 25, and 28. You had 5 problems to do. And I reminded you as you were sitting in here this morning, if you were early enough, to make sure you did it. So we did have a lot more people do their homework today. Well, a lot more people wrote something down for their homework. I am not a dummy. When I walk around and you have numbers that make no sense to the problem and you just randomly circle something, I know you really didn't do it. I still give you credit for faking it, but it's not going to help you at all in the common assessment. So it will show up on your test grade. But number 22, the answer is 60 meters. Does anybody need me to go over that? Yes, sir. All right. It says, what is the height of the object at the time of the launch? When I look at this equation, is it linear, quadratic, or exponential? Quadratic. How do we know it's quadratic? Because it has the x squared. If it has an x squared, it's quadratic. If it's all the variables to the first power, it's linear. And if there's a variable in the exponent, what is it? Exponential. So this is quadratic. It's a problem. And if it says, what is the height at the time of the launch? That means at time equals 0. How tall is it when it first gets launched out of whatever it's being launched off? So in other words, it's the y-intercept. So if you need to make yourself a note at what height is it launched, that is the y-intercept. So if you type this into Desmos, which I've got this calculator here, you had Desmos at home, but I'm just going to show you real quick here. Negative 5x squared plus 20x plus 60. And I'm going to adjust my window so that it'll fit. Well, you'll learn how to do that more when you get to high school when they give you these kind of calculators, but they're probably going to start using Desmos more. But here is what the graph would look like if we're just looking at the first quadrant, and you're looking for this point right here, and if you type it into Desmos and you clicked on it, it will tell you that's at 60, 0, 60. So the big thing is if you knew that it was the y-intercept. I want to point something out that I saw some of you with your answers on there. Some of you for your answer put 80, and I want to show you where you got 80 from. 80 is the vertex value, and 80 would be the maximum height. So if this problem had asked for the maximum height, you would have put 80, but it didn't ask for the maximum height. What did it ask for? The height of the object at the time of the launch. So when time was equal to 0, so that's when x equals 0. Does that make sense? So the big thing about these word problems is for you to know, is it asking for the y-intercept, the vertex, or the x-intercept? All right, turn to number 23. The stone's height in meters is represented here. About how many seconds after being thrown will the stone hit the water? What are they asking for on the graph?
How many seconds in the water?
Right, so what is that on the graph? Is that the y-intercept, the vertex, or the x-intercept? The x-intercept. And so after how many seconds did it hit the water? What was the x-intercept here?
Probably 3.
3 sounds right. I had the wrong equation typed in. I still have the equation from the last problem, so give me a second to fix this. Did the rest of you get 3?
Yeah.
It takes longer to do this in the old calculators, just so you know. I should have just pulled up Desmos, it'd been faster. Yep, 3 is the answer. It crosses at 3 seconds. So just so you know, this is what it would look like with the parabola. You're looking for where does it cross the x-axis, and that is at x equals 3 seconds. Number 24, what bracelet price should the company set to earn this maximum profit? I've already done this problem on another sheet of paper. I don't know why it's not written here on it, but it was at $4. Do you need me to go over that one? Yes, no, test this Monday. Mm-hmm. Okay, so when you're looking at the graph, the x-intercept, of course, is where it crosses the y-axis, and that is the height it was when it was launched, if it's a launching problem. Okay, so it would be here. Well, let me go back up here to this one, because this one actually looks a little different. But this would be the height it was launched. The top, the vertex, would be the maximum height, and the x-intercept would be where it hits the ground, the water, whatever is at sea level there. So that if they're asking for when it hits the ground, that's the x-intercept. If they're asking for how high it is when it's launched, that's the y-intercept. If they're asking for the maximum height, that is the vertex. but this one is different. So that's why I was like, let me draw a different graph here. So when I look at this graph, it kind of looks something normally like this. So the big thing you got to do there is figure out, Ruby, what represents the X and what represents the Y. That's your big thing to begin with. So when I'm reading the problem, it says the company's annual profit in thousands of dollars as a function of. When it says as a function of, the next thing it's getting ready to say is the X. So as a function of the price of the bracelet. So this is the X and the profit is the Y. Once you figure out what's X and Y, then it makes it a little bit easier after that. So they're asking us, what bracelet price should the company set to earn the maximum profit? Well, the maximum or the min always happens at the vertex. And so we're looking for the vertex, but are we looking for the X or are we looking for the Y? So here it said, what is the bracelet price? Well, bracelet price is the X. Profit is the Y. So here's what's happening. If I sell a bracelet for this much, I might not make much money. If I sell it for a little more, I make more money. If I sell it for this much, I make the max amount. But if I go over that price, less people are going to buy it. And then the more expensive I make, the less people buy it. Therefore, the profit is going down. So the max profit is going to happen at the vertex. The X value is going to be how much it costs. The Y value is going to be the max profit. So we're looking at the X value, which in this case was 4. The Y value would be the profit that you make when it is $4. And if I'm not mistaken, the Y value was like around 80. Oh, 8. Okay, I knew I said 8 in there. But then it says in thousands of dollars, which means $8,000 profit. So if you sold $4 bracelets, you'd make $8,000. That's what it's saying. All right, and then 25. The number of mosquitoes in Anchorage, Alaska, in millions of dollars as a function of the rainfall is in this. What is the maximum possible number? If it asks me for a max, is that the y-intercept, the x-intercept, or the vertex? Vertex. So the key is they're asking us for mosquitoes. Is mosquitoes the X or the Y? So let's go back and read. The number of mosquitoes in million as a function of rainfall. So the rainfall is X, the mosquitoes is Y. So in this case, we're wanting the Y value of the vertex. So if I go and I type that in, negative X squared plus 14X, I go to my graph. I got to get my max. You have to do it a little bit differently on this calculator. It's so much easier doing decimals. You just click it and it shows you the vertex. So it would be 49 million mosquitoes because the vertex was 7,49. Questions there? All right, one more from here. You had to do number 28. It says, consider the function. On which intervals is the function appears to be increasing? Select all that apply. When it says that, it's a big hint. You probably have more than one answer. So t is less than 1. That's right here. From less than 1 until 1, is it going up or is it going down? Down. And it asks us for increasing, so A is not the answer. B says less than 4. Here's 4. It's doing a lot of things less than 4. It's going down, then it's going up, then it's going down again. So can we select that whole interval? No. Greater than 4. After 4, it's just going up. So that is increasing. From 1 to 3, that's from here to here. Is it going up that whole time? Yes. And then 3 to 4 is from here to here. And what's it doing there? Going down. So C and D would be your answers on that one. Any questions there? All right, I'm going to have you do one problem and then a stretch break. I want you to look at number 29. I know it doesn't make a lot of sense. I want you to read it and see if there are any of the 3 that you can fill in. You might can't do all 3, but look and see, is there any of the 3 that you can fill in? And if you need to use decimals to type in some answers, you can. But it's saying if the function looks like this, which is vertex form, what does it mean if A is greater than 0, H is greater than 0, or K is greater than 0? So take a moment, see what you think. After you've had a minute or so to think and get your thoughts together on that, we'll go over it and I'll give you that stretch break. All right, so looking at this, let's just go through. This is vertex form. A actually tells us two things, but there's only one thing we can write here for this A value. Did anybody figure out what we should have put there for the A value? I didn't hear you. You could put 1 in, and if 1 is there, what does it make the graph do? Anything greater than 0. So if it's positive, if A is positive, what does that tell us about the quadratic parabola? It points up, opens upward. And so what I wanted you to get out of this problem is if A is positive, it opens upward. If A is negative, what does it do? Opens downward. All right, then we get to H, and I'm actually going to pull up Desmos to show you something here. Do you know there's a minus sign in front of H? That minus sign is not included in the sign here. So it's saying if I put a positive number in there, so like if this is X minus 3, and you would say, well, that's negative. Yes, but it's a positive 3 for the H because there's a minus in the formula. Does that make sense? So if I put X minus 3, what does that do to the graph? It moves it to the right 3, actually. So if H is positive, it moves right. And if H is negative, it moves left, which is obviously what we think because we're not thinking about the minus. So pretty much if you see minus a positive number there, it moves right. If you see plus a positive number, it moves left because plus a positive actually minus a negative. And then the K on the end, if it's positive, what does that do to the graph? Moves it up. Or you might see the words vertical shift up. Now, I told you A tells you one more thing, but it doesn't apply to this. A also tells us if it's a vertical stretch or a vertical shrink. If it's a vertical stretch, the absolute value of A would have to be bigger than 1. If it's a vertical shrink, fat fractions, the vertical absolute value of A would have to be between 0 and 1, a decimal or a fraction, right? All right, go ahead and take your stretch break, and then we'll do some more problems.